Good morning, Professor Wong. Shall we start now?
Sure.
Okay. Good morning, ladies and gentlemen. Sorry. Professor Wong. Okay. Let's start our webinar today. Welcome to our webinars on the Industry 4.0 and the developing world, digital dividend and digital divide. I'm very glad to see such a good turnout today. And we are having our participants from more than 12 countries to attend our webinar. Welcome, everyone. As we are marching into the new era of Industry 4.0, it is important for us to understand the implications of technological innovation, in particular on how digital technology is changing the way we live and work, and how to get the most out of digital revolutions in bridging the digital divide and building digital dividend. It is a great honor for me to introduce to you our speaker for today's webinar, Professor Wong Po Kam. Serving as a professor at the National University of Singapore Business School and professor by courtesy at the Lee Kuan Yew School of Public Policy, Professor Wong is a highly reputable researcher in the field of entrepreneurship and innovation. He is ranked among the top 2% most highly cited researchers globally by AD Scientific Index. To tap into his expertise, Professor Wong has been invited as a consultant by a number of international agencies, such as the World Bank, OECD, and the Asian Development Bank, and many Singaporean government agencies as well as corporations in Asia. Also, Professor Wong has contributed significantly to the development of entrepreneurship education, not only in Singapore, but also in other countries such as Indonesia and China. To recognize his contributions in entrepreneurship education, the Singapore government has awarded Professor Wong the Public Administration Medal Silver Award in 2013, and in 2015, Professor Wong received the Entrepreneur for the World Award Educator category from the World Entrepreneurship Forum. We are indeed very privileged to have with us such a distinguished speaker today, Professor Wong, to share with us on his view on our Industry 4.0. If you have any questions or comments to ask Professor Wong, You may type your questions or comment in the chat box. We'll address your questions later during the Q&A session. Without further ado, let's welcome Professor Wong to deliver his talk. Professor Wong.
Good morning, everyone. I hope you can hear me well. As an ex-Malaysian who grew up in Ipoh, Perak, I am delighted to have this opportunity to have a virtual Hui Xiang or Balik Kampung. Professor Cheng has asked me to share some thoughts about how the fourth industrial revolution may impact the developing world, especially Malaysia and Southeast Asia. I would like to do this by perhaps from two different perspectives. One is, as Professor Cheng had mentioned, as a professor in NUS Business School, I've been doing research on innovation and entrepreneurship in Asia and Silicon Valley and so on for the last 30 years. So that's one perspective that I will try to bring to bear on this question. The second is of my role as an investor in technology startups, having been an angel investor in about 2,000 tech startups from around the world, and more recently as a limited partner and advisor of a venture capital fund. I would sort of welcome a good dialogue and discussion with everyone, but perhaps I can start by just going over what we mean by the fourth industrial revolution, right? I think as this picture shows, generally the first industrial revolution is recognized as the era of mechanization, water and steam power. And the second industrial revolution was when mass production assembly line and electricity became widespread. And of course, the third industrial revolution is when computer and automation become widely adopted. So what's so different with the fourth industrial revolution? I guess one way to think about it is really what is here mentioned as cyber physical system is really a pervasive integration of digital technology and digital network with physical system. So it is this pervasive integration that really gives it that transformational power. Now, I think a lot of you may have read about the World Economic Forum's report on the fourth industrial revolution. In fact, they are the one who made popular the name, and they have listed here, for example, a major trend that have been enabled by the so-called fourth industrial revolution technologies. I obviously won't have time to go through all of them, but I will probably use a small number of these really to try and illustrate how and in what sense the fourth industrial revolution is going to be significantly impacting people in the developing world. But let's take a step back before we get into a little bit more detail. Take a step back and take perhaps a macro historical perspective of how technological change actually affects society, right? I have included here a picture that is extracted from the latest UNCTAD report. And as you can see from the headline here, that technological change has historically widened inequality. You can see from this diagram that the red color refers to the average per capita income of people in the so-called advanced economy. UNCTAD call them the core countries. And here are the blue line are the average income of people in the rest of the world, which is the majority. And as you can see, while over time with technological change, everybody's average livelihood, everybody kind of improve, the gap between the advanced country and the developing country has widened. Now, of course, technological change is not the only factor, that caused this widening of inequality. We know, for example, that colonialism, I mean, it does bring some development to the colonies, but it has a much bigger effect of transferring, and some would say plundering the wealth and resources from the developing country and transfer them to the core, right? Nonetheless, you could still recognize that technology has been a major driver. In fact, you may even say that it is the superior technology of the advanced economy that perhaps enable them to go on this colonial conquest. So the natural question that can be asked is that would this current transition from the third industrial revolution to the so-called fourth industrial revolution have the same effect? And of course, many people, and I guess maybe part of the reason you are listening in is because you share a concern that many people in the developing world had, which is that it's going to have major negative impacts, right? The UNTAC report, for example, highlighted these 4 concerns, right? Which is reflected in many other forums, yeah? So first concern, of course, is that would in the increasing automation eliminate job for human? In the third industrial revolution, a lot of the jobs that were eliminated were blue-collar workers. But now increasingly, in the fourth industrial revolution, a lot of the white-collar work will be gone, right? Then will it create job polarizations, right? Maybe, the highly skilled, highly knowledge-based job will still be there and maybe even increase significantly, but the rest of the people may end up doing really sort of low-level service work that the robot cannot take over yet, yeah? And related to that, of course, you have the so-called gig economy with no job security and no labor rights. I think some of you may have read, for example, that Amazon, right, has so far resisted any unionization of their workers. And if you're a Grab driver, you have no benefits, you have no medical health insurance or whatever help, right? So would it lead to more and more people in the gig economy and a few privileged who have the right skill and qualifications to end up with high-end jobs, high-paying jobs, yeah? So increase in inequalities and market power concentration is right underlying many of these concerns. You see around the world today, the big global giants, the Facebook, Google, Amazon of the world, right? They control so much economic power, yeah? So even though UNTAC has projected that the market for fourth industrial revolution technology is going to significantly grow in the near future, the question that many people ask is that, will it worsen inequality within a country? And also, will it help your country, assuming you are from a developing world, to catch up more with the advanced economies? So maybe we should take a poll here, yeah? And Professor Ching, perhaps you can help call up that poll now.
Okay, sure.
And I guess for those of you who are not from Malaysia, I understand some of you are from outside Malaysia. You just answer this question with respect to your own country, okay? So I will give everyone maybe up to a minute to try and answer. Don't think too much, just give your gut feeling, your gut concern, yeah. Okay, the 1 minute is up, so I'm going to end the polling. And let's look at the result. Okay, this is what you have responded on the first question. Well, 60% of you are pessimistic. You think that fourth industrial revolution will worsen inequality in Malaysia. And on the other hand, however, you are optimistic that, or rather, almost 80% of you are optimistic that 4IR will give Malaysia the opportunity to catch up more with the advanced country. Okay, right. So with that, we will move forward. So I guess what I would say is that, yes, you are probably right, but I want to sort of have you to think about the relationship between inequality and income mobility. Now, I'm drawing on the work of my colleague at the Lee Kuan Yew School, the Dean of the Lee Kuan Yew School of Public Policy, Professor Danny Kua, who, by the way, is also an ex-Malaysian, Penang boy. He's actually the classmate of my wife. Very well-respected economist who was previously the head of economics department at the London School of Economics. In a recent study, he looked at the question of the relationship between inequality and income improvement of the bottom 50% of the population. Now, as you can see from this chart, there is almost no correlations. Now, I just want to highlight, for example, here that the United States, the x-axis measure some kind of measure of the level of inequality in the country. And the y-axis here measure the rate of improvement in the income of the bottom 50%. So here in the United States, one of the most unequal country in the world, and there is very little income improvement of the bottom 50%, right? Over this 20-year period, it is just slightly over 1, right? Which means that it hardly changed. No actual improvement to the income of the bottom 50%. And then at the opposite end, you have a country like China. China had relatively lower level of income inequality than the United States, but it is a world leader in terms of remarkably uplifting the income of the poor. So the income of the bottom 50% in this 20-year period increased 4 times. So remarkable achievement. And then you have a country like Singapore, where we have also relatively high level of inequality, but we also have reasonable income mobility of the bottom 50%. Their income double. Okay, so the first thing is that from the analysis, the level of inequality does not predict income mobility of the bottom 50%, right? Now, this next chart shows the relationship between level of income inequality and the change in the level of income of inequality now. So again, in the United States, there is a bit of increase in income inequality. It's about 1.5, right? Times, right? The income inequality become worse, right? But what is interesting, and again, there's not much correlation between the two factors. Again, you look at China. China, in the previous chart, we know that it had done a marvelous job in raising income of the bottom 50%. But China also is an outlier in terms of the significant increase in income inequality. Granted that it starts from a low base, but still, it has a big increase in income inequality. So, therefore, what is interesting now is that this third chart, which actually shows that the rate of increase in income inequality I'm sorry, on the bottom here is the rate of improvement in the income of the bottom 50% compared with the increase in income inequality. And this chart shows that there is a high correlation. That means countries where they greatly improve the livelihood of the bottom 50% also at the same time have increasing inequality. So therefore, maybe the digital divide and digital dividend is a kind of a false dichotomy, that it seems to both increase. And I want you to sort of take this to recognize, therefore, that while you may be very worried about increasing inequality, what you should be more concerned in the first place is, does the income of the bottom 50% improve? Does the livelihood and quality of life of the majority of your citizens improve? So if it improves, even if there's an increase in inequality, it's not so bad, right? And I want to use this to really lead up to my main point, which is that the fourth industrial revolutions, much more so than previous generation of technological change, creates great potential for improving the life of people in the lower income and in the less developed countries. And it does so by dramatically lowering the cost and technological barriers to bring innovative solutions to these people. Now, let me show you this chart, which share with you what you may already have heard or know, which is a dramatic fall in digital technology costs. The first diagram here shows the familiar drastic drop in cost of the transistor, right? It is increased by, I think, probably 100 billion times, right? The cost drop is tremendous. And then the cost of disk drive prices, and then the cost of internet connections. So cost of computing, cost of data communications has dropped tremendously. And here on the right-hand side, you can see the drop in the cost of robots, right? The cost of having robots has also dropped tremendously. And the right-hand side, and sorry, in the bottom one here shows you also a significant decline in what is called edge computing, meaning that until recently, practically all devices are pretty dumb. Your light bulb, your thermometer, your whatever, they are pretty dumb, right? They are standalone. But now you can make devices smart. You can put a chip, you can put a computer on devices. And because the cost is so low, you can actually reach significant sort of decentralized smart devices at very low cost. Now, this is happening all across. This chart shows you the cost for genomic sequencing of the human genome. I think all of you may have heard of all the fanfare about, sequencing the entire human genome, right? The so-called Human Genome Project that was completed in the year 2000, and it cost well over $1 billion, right? Today, you can get your gene, your unique individual gene, to be sequenced for about $1,000. So rapidly declining cost means that technology become much more affordable. And added to that, you have the digitization, have the effect of modularizations. And this dramatically simplify the way in which you build complex systems. Because remember, the fourth industrial revolution is about integration of digital technology and network with physical thing. The physical thing could be an advanced material, it could be a biomedical device, or it could be a complex machinery like a car. But the whole point is that today we can do these integrations very easily because everything is modularized. You have on the one hand the IoT devices, which have sensors and actuators, and they can send the data through the internet, and then they get sent to the cloud to be analyzed, and then come back with the either instruction of what to do or give you insights. And of course, you can also send information to a human on a smart mobile phone remotely. Yeah. However, as the IoT devices become smarter and smarter, they are able to actually do most of the computing and analysis themselves without having to send the data to the cloud. Okay, so, and all this now can be much more easily done. In the past, in the third industrial revolution, many of the so-called information systems are complexly integrated, but today they are all modularly integrated. And that again dramatically reduces the cost and time to build new innovation that integrate digital and physical systems. Now, I'm going to illustrate it with a simple example that I have seen in Indonesia. How is an entrepreneur were able to apply IoT to innovate small agriculture farm. This is in Bandung. Yeah, as you can see, these are pictures of the actual farm. Now, the conventional way to actually run an agriculture farm is to have a laborer who will carry the food that the fish need to eat and disperse them into the by hand. Yeah, throw them into the farm. The food for the fish would easily account for 70 to 80% of the operational cost of aquaculture farm. What this entrepreneur does is that he built a device, you can see here, that essentially a storage tank that store the food for the fish. And there is a sensor at the bottom of this, of the nozzle that dip into the water. Now, this is actually an audio sensor. Now, what happens is that fish, when they are hungry, emit a different sound than when they are full. And so the machine here listen out to the sound of the fish, and when the fish are hungry, it releases the food out. And when they hear that the fish are getting full, it stops them. This has the advantage that first, it economizes on the food. The traditional way, there's a lot of waste, a lot of food that get thrown. And of course, the laborer sometimes also pilfer, they steal some of the feed, right? And in this case, you are much more efficient in the cost of the feeding. And incidentally, I'm given to understand that different species of fish emit different sounds. But there's no problem because the chip can be programmed to listen out to the sound of different fish infinitely. Yeah. But what is interesting is that, of course, is that this is also connected through the internet. So the owner of the farm can on their smartphone see what is happening. And more importantly, because of the data that is collected, you can now build a model that can correlate the fish productivity as they grow with the food that you feed. And you can now predict more accurately when you have a harvest. And now this information is out in the cloud. And your customer, the supermarket, can actually see ahead when you may have fish that may be ready. And the bank now has a better way to assess the credit worthiness of this small aquaculture farm. Because in the past, many of these small aquaculture farms cannot get bank lending or insurance or whatever, because there's no data and their farm is so remote, very hard, very costly for the bank to come and inspect and do credit worthiness check. And now with this information, it allows the even small aquaculture farm to be able to attract financial support, financial services. So this simple example kind of illustrates what you can do. And the point I want to make is that IoT for Industrial Revolution is not about rocket science. I bet you that any good engineering student in Utah or other good universities can design the system. Okay, the key is to have an understanding of the problem that you need to solve. Now, in this case, this entrepreneur, he himself came from a small aquaculture farm family. He then went to study engineering or computer science, I can't remember, in the Institute of Technology, Bandung. And so here's an example of an entrepreneur who applied his knowledge and skill, and then effectively implement an IoT applications that is significantly improve the productivity and the ability and the viability of the business. So the fourth industrial revolution is not just about, very fancy, sophisticated technologies. It's about really how you use digital technology and network to make your traditional physical system more productive, more useful. Now, I'm going to give you another example of a low-cost IoT innovation. On the left-hand side, you see an old electricity meter, right? This is still widely used in many countries, probably including Malaysia. The disadvantage of this meter, of course, is that the only way to read the meter is to have a human to stand in front of the meter and write it down, right? Now, of course, some of the leading sort of third industrial revolution company have built so-called smart meter. But this meter, all this meter does is that it is electronic, and you can send the data via the telephone network to headquarters where they can read it, yeah? But it's still pretty dumb, and it's expensive still, which is why many of these meters, still are not being replaced. However, here's an example of a Chinese company have a simple low-cost innovation. What it does is that it uses a simple, these digital camera, these cameras are very cheap, and a small transceiver, and he fixed this, he just fixed this right in front of this mechanical meter. So now, if you want to read the meter, you just send instruction and it take a picture, snap, whenever you want, right? So it does practically the same job as this at a fraction of the cost. Now, again, I want to sort of emphasize that, IoT is not just about the cutting edge. You could actually, if you have the ingenuity, even in poor, low-income country, you could already do a lot. Now, of course, you can actually have leapfrogging innovation. In here, I want to show you a brief example of a really what they call truly cutting-edge digital meter that's introduced by a company called Eneco in Singapore. I want to disclose that this is a company that I've invested in as an angel investor, and I'm on the board of this company. Yeah, I'm going to just.
An intelligent sensor network, without doubt, is the key component of smart energy management. By understanding the essential needs for energy management, we have created the Tesseract. A device vastly faster and more powerful than any smart meters available in the market, the Tesseract revolutionizes the meaning of smart metering. Powered by ARM Cortex processor, the Tesseract provides advanced encryption capabilities and delivers 40 times more processing power than the most powerful smart meters available. The Zhong metering system on chip provides an impressive class 0.2s accuracy, sampling rate of 10,000 samples per second, surpassing the industry average by over 160 times with its 10 GB flash storage memory. The Tesseract is further supplemented with FRAM non-volatile memory, allowing it to have 100 million times more write cycles than standard EEPROM chips. Expandable to 12 input-output ports, the Tesseract is able to capture information from other devices and control multiple external equipments. First in the world EMC-safe capacitive touchscreen framed by fire-retardant grade glass-filled polycarbonate casing, providing unparalleled user experience and interface flexibility. Compliant with the most advanced Internet of Things protocols, the Tesseract is compatible to an extensive spectrum of communication network, including Zigbee, Wi-Fi, 4G, NB-IoT. First metering device to adopt an app ecosystem architecture, the Tesseract is powered by the Android operating system.
Okay. For those of you who are not into technology, this may sound boring, but basically what it just says is that the company had put the same smart computer technology on your mobile phone into a meter. And this meter is so powerful that it doesn't need to actually send a lot of data to the cloud. It had enough computing power to do all kind of data analytics on the meter itself. You can, for example, if you put one of this meter in your house, after a while, it will be able to recognize exactly how much energy is used by every electrical device in your home. Because, for example, the refrigerator you have in your house generate a different harmonics from that of your microwave or from that for your aircon. And the computer on this meter can figure out after a while, which is which. And there is a worldwide database that will tell you what is the digital signature of every device. You can even tell the digital signature of a Samsung refrigerator from a GE refrigerator. This is what I mean by modularizations. You don't have to reinvent the wheel. The data are there. And so you design a system that is smart enough to tap these. And we are using all standardized technology. We're using Android system. So it interfaces with any other Android system. So the point I'm trying to say is that actually this could have been built by the leaders of the old meters of the world, but they don't, because they are wedded to the old technology. When they improve, they were still using old technology. So very often, new revolutionary innovation is not done by the market leaders in the old paradigm. It takes a new firm some time to be able to do what you may think is obvious.
It can be installed with a wide range of
Okay, so as you can see, IoT is just one of the 4IR technology, but it is the key to more efficient and distributed renewable energy system for large cities. In the good old days, electricity are generated from a small, big power generator, and then they are distributed with, this big sort of a transmission system to your house or to your factory, one way. In the future, we have millions of energy being produced from wind farm, from the solar panel on top of your house, from biofuel in your backyard. And these now can be transmitted back to the system and shared. So it's a two-way system. But for this smart grid to work, you need the core IoT technology. And by the way, this is needed not just for large cities, but also for rural villages. And that's why now actually, because it dramatically reduced the cost of producing electricity, millions and millions of people in the rural poor in the developing country who have no access to this electricity grid because it's too expensive to extend the transmission to such rural places, they now can get electricity through low-cost microgrid. And this can be built up very low cost because you're using standardized network interface, standardized components. Again, any student at Utah will be able to build one of these, I'm sure. Again, if you put your mind to it. Now, the other major things that, of course, a lot of people are talking about is cyber cryptocurrencies. I would rather actually talk a little bit about blockchain, because cryptocurrency is built on blockchain. Now, you all know that back in the 1500s, the invention of the double entry ledger revolutionized finance and commerce and made Venice the financial hubs of the world, right? A blockchain is nothing but just a ledger, but it's distributed and it's digital. And again, because it is connected to a pervasive network, it is now able to probably revolutionize finance and commerce in the same way that the double entry ledger system had done in the past. So the key advantage of blockchain, again, drawing on this pervasive digital integration, is that it's decentralized, it's transparent, it's immutable. You know, in the old way, you have a book that actually keep the entry. You know, it is at one place. You know, and people can make change to it, and you never be sure that whether they make the change. So the advantage of blockchain is that therefore it enables authentication without intermediaries. Because in the past, things cannot be trusted, so you need to go through a trusted intermediaries. You want to deal with anything, you go through a lawyer. You want to go through a financial transaction, you go through a bank, right? Now, therefore, with blockchain technology, you bypass the intermediaries. And this results in faster transaction, lower transaction costs, and also it gives you true traceability. You will know who made what change. Nobody can make any change without the system recording it, right? So let me give you that. Now you may say, therefore, okay, all the limelight about blockchain is about cryptocurrency, Bitcoin, all that. Let me give you this example of the use of blockchain in the refugee camp. Okay, I hope this example kind of illustrates the power of the fourth industrial revolution technology to solve some of the world's biggest social problems, yeah? And to do it without paying the cost of the costly old system. Remember that the bank charged a lot of money, and so you bypass the bank. Just one of the possible benefits of this system, yeah? And for people with no identity, they cannot prove, they cannot authenticate themselves. This technology, again, help overcome that lack of trust, yeah? Now, for some of you, since many of you are students, you know, I'm sure you have to deal with the challenge of a certificate, right? Right now, you still get a physical piece of certificate. And for those of you who are involved in the HR role in big company, one of the big challenge is that how do you know that a copy of that certificate is not a fake? You can get it certified, but how do you know that the certification itself is fake? Right? Again, blockchain can be applied in principle to actually authenticate that your certificate, and the HR of the company that you're applying for doesn't even need to ask you to submit. They can just cross-check through this blockchain system, provided that your certificate is already on it. I'm an alumnus of MIT, and MIT a few years ago have now started to issue blockchain authenticated certificate, so that you, whether you're applying for jobs or whatever. So this is an example of applications that again have great sort of potential, and it help cut out a lot of cost. You don't have to wait for copies to be, made, wait for the university to respond, to survey, and so on. It's done instantaneously if everybody kind of adopt this system. Yeah. Okay,
Imagine.
in the interest of time, move on. Now, I will quickly run through another example of how the dramatic drop in cost is helped in this case in the life sciences is having a tremendous impact. Some of you may have heard of this about the so-called CRISPR technology for editing gene. We don't need to understand the detail about how this works, although it's actually quite simple. Once you see what they've done. The story I want to tell is that as a result of the COVID-19, everybody is working to find solution to do tests, right? And I show you here a team from Nanyang Technological University in Singapore. They were able to, within a short period, develop a rapid test for COVID-19 infection. And the way they did that is by using CRISPR technology. So my point is this. With CRISPR, the cost is so low and is much more efficient. You can get things done much faster. Without CRISPR, the team would probably have taken much longer, or only a small number of very advanced technology lab in the world will be able to do it. With CRISPR, frankly, any country with big, sufficiently trained personnel can develop this. I want to give you also another example of how CRISPR can be used to solve a major problem in the developing world, malaria. Malaria, of course, is a tropical illness that is caused by a parasite that the mosquito spread from person to person, right? It is a major problem. Now, one of the sort of innovation that is being developed now is to use CRISPR to actually change the gene of the mosquito so that it is no longer able to transmit the parasite. So it is not getting rid of the parasite. It is making the mosquito being unable to transmit it. So this illustrates to you the power of CRISPR gene editing technology, but also show you how it can be applied to solve major social problems that affect the rural developing world. Now, a lot of the people who express concern about growing inequality and domination of 4IR by large incumbent third IR firms from advanced countries, I have good news for you, which is that despite all the hype, many of these firms are actually quite slow in adopting 4IR. As you can see from this chart, it's probably not clear enough. The only technology that kind of have been adopted to a significant degree is cloud computing. Even IoT, for example, is between not adopted yet and starting to adopt. And practically most of the other major technology is still at a stage where they are being evaluated. Now, as a scholar on innovation, the literature tells us clearly that many incumbent firms tend to invest in sustaining innovation, but not disruptive innovation. You all know about the example of Kodak, right, which is the world leader in imaging, right, chemical film. But they were slow to switch when the world is switching over to digital imaging. It's not because they have no money. It's not because they didn't know that this technology is coming, but they're just either legacy. They don't want to cannibalize themselves, and there's also organizational resistance. There is hubris, and so that's why anytime when there is a disruptive innovation, it tends to be introduced by firms from outside the industry, or by new startups, including latecomer firms from the developing world. This is what is called Schumpeterian destruction, yeah, where the leaders in one generation get destroyed by the new firms when there is a change in technology that is radical. So I therefore argue that the 4IR technology, now not all 4IR technology are disruptive, but those that have a disruptive effect are more likely to be commercialized by latecomer firms, by new firms. And therefore, it provides an opportunity actually for firms from the developing world, firms from Malaysia, from any part of the developing world, to leapfrog incumbent 3R leader in advanced country. Remember the smart meter by Eneco that I talked about? Well, they were not introduced by the world, the existing leaders in meter making, you know. They were introduced by relatively new firms. That's why a lot of 4IR technologies are increasingly being commercialized by new tech startups, with private venture capital being the main driver. As this article in Forbes show, yeah. Now, I here show you some example of 4IR tech startup that a venture capital fund that I'm an advisor and limited partner for have invested, yeah. Just to give you some sense, yeah. The company have invested in Eneco, which I mentioned. We have also invested in, for example, a drone company, which is a leading drone company in Japan. And we have also invested in two of these gene editing related company, Twister, which is now listed on NASDAQ, and Inscripta, which is trying to build a whole CRISPR technology into a box that you can put on your desktop. Just like in the old day, a computer occupied a whole room, in the future, a CRISPR machine will be like a laptop. And so you can see that it is high risk, but this is where venture capital are driving a lot of this new 4IR. And iGroup partner actually invest globally. We look for technology from anywhere, yeah. And we have recently invested in a sort of a fintech company, which is in Philippines, for example. So my point is that even though advanced countries have a lot of advantage in the ZIR technologies, there is tremendous opportunity for firms, entrepreneurs from the developing world to actually leapfrog them. So the point I want to sort of highlight about the opportunity for leapfrogging, I want to highlight that China is a great case study of how a latecomer economy has caught up and in many cases leapfrog over the advanced economy in not so much inventing, but in applying 4IR technologies. Now, there are two sort of major set of factors that actually explain why China has been able to sort of be now the world's leading adopter and deployer of 4IR technologies. I think the first is to recognize that it's a high adoption readiness of the people and of small businesses, right? China today have more mobile internet and consumer in the world, more than the EU and the United States combined. And importantly, 95% of these internet users are on mobile platforms. Today, more than a quarter of retail sales in China are done through e-commerce, twice the rate of the US. And overwhelming share of the e-commerce are done through mobile. And the penetration of mobile payment in China is very high, right? In many parts of China, you cannot pay with cash. So we are not talking about really cutting edge technology. What we are talking about, actual adoption. The technology is already available. Any developing country in principle could adopt this if the right infrastructure and if the readiness of the people to adopt is there. And of course, one thing that helped in the case of China high adoption is that there's high user trust in the government. that somehow that the data may not be misused for whatever reason, and then the government will take certain action against companies that are sort of misbehave. So of course, the other factor that helped China to achieve this rapid deployment is that it's enabling public policies, right? In order for mobile app to be used, well, you have to have mobile networks. Who build the mobile networks? Initially, you need some public sort of funding support to get it started. Although once you reach a critical mass, then it becomes a commercially viable proposition, and private enterprise can take over on a profit basis. But in many cases, this has to be done perhaps through a public investment. Now, in China, the light touch regulation in the early years are important to allow free entrepreneurial experimentation by private enterprises. So the Alibabas, the Tencent, all these internet mobile company were free to experiment. Very little control. It is only in more recent years, in fact, that you see the government start to impose anti-competition control, because when this company become too big and become too arrogant, the government needs to step in and make sure that they don't sort of stifle new startup and so on. Yeah. And you also have a government policy that actually encourage inclusive development applications. So Alibaba, for example, basically helped revolutionize the whole countryside by enabling many small producers in small villages to be able to sell their goods through Taobao and so on, right? And so this focus on the needs of the lower income, on the need of the rural population, in other words, on the need of the emerging market, is actually what helped them succeed. Now, I don't know how many of you know when Alibaba first started, they were smaller than eBay. And when they introduced Taobao, eBay was already in China. Now, in what way is Taobao different from eBay? Anyone? Some of you may know, but one key difference is that is the business model. In the case of Taobao, small businesses don't pay any fees to list their product on Taobao. There's no commission on the sales as well. Whereas in eBay, you have to pay commissions. Now, why is it important? Because when China first started, many of the small businesses are very small. They don't have much money. And so in order to reach them, you need to adopt a business model that is suitable for that low-income small business market. Now, Taobao eventually make money by essentially through advertising, right? And because China market big enough, and then e-commerce pick up the advertising help. I want to use this example to illustrate that very often leading companies from advanced country, they don't understand enough of the market in the developing world. And so even if they enter earlier, local entrepreneurs can defeat them. You know, Uber, for example, was in Indonesia before Gojek started. But Gojek easily overtook them because Gojek understands Indonesian market. They know that, for example, you know, the four-wheelers is not a good proposition because of the traffic jam. And so they started with the two-wheelers. And with the two-wheelers, they understand that in Islamic society, a woman rider has to go with a woman driver. And so these are not technology, you know, these are market insights. Uber could have done this, but Uber entered with a four-wheeler. Uber didn't introduce this thing. And so my point is that local entrepreneur from the developing world, if you truly understand your market, if you truly focus your entrepreneurial energy on developing solutions to meet the lower income and the specific needs of your society, you have a chance to beat and leapfrog advanced country firms. And you can see here that in the case of China, also they are encouraging the Chinese company, when they go out, don't compete directly with the advanced country, go to the emerging country. So when Huawei first started, it didn't try to compete with the United States. It went to the less developed country, the so-called surround the city from the countryside strategy, right? So it's a question of targeting the right application of the fourth industrial revolution. Don't copy and try and do what the advanced countries do. I just add to this is that China, for example, is pushing on renewable energy, because renewable energy, as I mentioned before, is the basis for a truly smart distributed energy system in the world. So today, and again, most of these technology when China first started, they are not the pioneer. They are just using what is out there. It's intelligently applying them. But of course, over time, China now has become the leader in a wide range of renewable energy. They dominate in the solar panel, they dominate in lithium-ion battery, and they dominate in wind energy. Now, so the point I want to highlight is that China rapid technological catch-up start with innovation application, not with trying to advance the frontier of technology. That come much later. In China, way in the first decade, they spend much less R&D than the advanced country. And the reason they are able to achieve so fast leapfrogging in the for IR technology is because they are focusing on applying, not on inventing new one. But of course, over time, once China reaches a stage where it is close to the frontier now, and also because of the technology war that is started by the United States, they have no choice but now to intensify at the front. And so today you can see that China, where China is leading the world, is actually in a number of key 4IR technologies, right? In 5G that you all heard about. And some of you may not know that Chinese companies today are the world leader in global blockchain applications because of China's government also strong push to develop digital currencies. Now, we all know that a lot of time, therefore, a lot of the 4IR technology are actually already available. But the reason they have not been widely adopted yet is more because of organizational resistance. Now, this chart here shows you some of the so-called, in fact, already widely available technology that previously were not adopted, but as a result of COVID-19 is now widely adopted, right? A lot of you work from home. A lot of you have remote education. In China, for example, telemedicine is now a big thing. Yeah, the Ping An, which is had a sort of a Ping An good doctor, had I think something like 300 million users, right? So I believe that to the extent that COVID-19 has kind of upended the traditional way of doing business, it is actually good in terms of catalyzing the adoption of many of these technology, which is already available. So just to re-emphasize my point, the Industrial Revolution, fourth Industrial Revolution is not about inventing new technology. It is about using what is already out there. So just to summarize then is that all developing countries, including Malaysia, Southeast Asian countries, we all have the potential to reap significant digital dividend. But to do this, you require entrepreneurial mindset and a strong desire to understand and serve such needs. In other words, don't look at what is happening in the advanced country. Look at your own country. Look at a country like yours and say, how can I use already available technology to develop new solutions? And to the extent that you can actually be able to have a disruptive solution that will even give you more advantage. And of course, just as we learned from the case of China, you do need a strong government role. Government role in terms of investment in enabling infrastructure, and why it is important to build a vibrant entrepreneurship support ecosystem. Because what you need is, a lot of people with the entrepreneur mindset to come up with their own solutions, and they can do it. But there need to be the support ecosystem. There need to be the angel investor. There need to be the incubators and so on. And that's why in my last 20 years in NUS, as director of NUS Entrepreneurship Center, I have focused on helping to build the entrepreneurship support ecosystem. Yeah, so that in fact many of the startups that came out of it are started by graduate like you all, right, in the audience, and you can start companies that use 4IR technologies. And the other thing that will help is that if your government have a policy that actually prioritize inclusive development. In other words, everything else equal, you want to encourage and give subsidy and funding to solutions that solve the social problem in your country. Don't focus on the need of the rich, focus on the need of the common folks in your country. And of course, the government has the role to train and retrain the labor force who may lose their job from industry that has declined from the third IR, to get them ready to have the skill to serve the fourth IR. And lastly, of course, you need to have government, you need to build trust with the people. The reason many technologies are not adopted is because people have no trust. So I want to end my talk by arguing that from a social entrepreneurship perspective, 4IR technology has the potential to be used to do good as well as to do well at the same time, if you have the right entrepreneurial purpose and business model. And so the issue about whether 4IR will be able to give good digital dividends is really about, can we sort of find ways to incentivize entrepreneurs to actually to both do good and do well. And in a sense, in the longer run, what we need is a major shift from the shareholder capitalism system that has dominated previous industrial revolution eras to what is now called a stakeholder capitalist system. So the idea here is that businesses are incentivized to not just generate profit for the shareholder, but they are also incentivized to respond to investors who demand that their business comply with environmental sustainability and so good social impact and proper governance and ensure diversity and no discriminations. And also you need socially conscious consumer and employees and perhaps a government policy that encourage inclusive development. Now with this kind of pressure, then businesses and entrepreneurs will then think about business model and solution that is both profitable and generate positive impacts. I want to end by talking about, therefore, this: how do you integrate social purpose into business movement? Because until you do that on a larger scale, the full potential of 4IR for doing good will not be realized. A B corporation is actually a way for a company to be certified to say that they not only will try to give a good return to the shareholder, but they are committed to achieve some good social impact. And they are committed to be transparent, which means that just like every year you report what is your financial performance, you also report your progress in giving good social impact that you declare you believe in. And there's a company called B Lab that actually is involved in providing this third-party certification. So it's like you doing an ISO 9000, right? B Lab will come in and help you to actually look through what are all the things that you need to do and what are the metrics that you need to put in play, what are the measurements, and every year you report. B Corp has started in the North America and Europe, and today there are more than 3,000 over companies that are on that are B Lab certified. Here is a list of some of the example of company. You can see here a company could include Danone, which is a big French sort of a confectionery company. It also include company like Coursera, which is involved in the digital education, and The Guardian, which is a leading newspaper in UK. I'm happy to say that I'm involved with setting up the B Corp for Southeast Asia, and I'm a director of the B Corp Southeast Asia. And what we hope to do is to encourage more companies in Southeast Asia to also be engaged in B Corp certification, so that we move forward more and more companies that are committed to both do good and do well. And I believe that 4IR technology will then be able to be more effectively used to give the kind of digital dividend potential that I talked about earlier. I was going to give some example, but in the interest of time, I will stop at this point. And I will pass perhaps to Professor Ching, if you want to moderate any question and answers, or if anyone want to perhaps pose your question and answer, your questions on the chat box or whatever.
Thank
Professor
you.
Ching.
Yeah, thank you so much, Professor Wong. I think we all learned a lot. You know, you have discussed so many things about this in the different aspect of this industry 4.0, and maybe we have some misconception before, like thinking that there's a technological gap between the developed and developing countries, and that actually hinder the developing countries to benefit from this fourth industrial or industry 4.0. So, but you actually given many good examples on how actually developing countries like Malaysia can actually benefit from this industry 4.0. And we do have some questions from the audience. And audience, yeah, please feel free to pose your questions here in the chat box, or if you want to use your microphone to ask the questions, you're welcome to do so as well. But I do have questions from when you discuss about this distributed income, you know, distribution, this technological advancement actually help to uplift the bottom 50, but at the same time also create higher income inequality. So does it mean that during this industry 4.0, the poor become poorer and the poor become richer, but the rich will become richer as well?
Well, if I understand your question is that
what?
Is it a zero-sum game or is it a zero-sum game? Yeah, I guess from my earlier sort of part where I talk about, you know, income growth of the bottom 50% and the overall level of inequality is not a zero-sum game. Of course, it could be a zero-sum game in some cases, but generally, depending on what business model are being implemented, it's not a zero-sum game. Then it's a question of how much of the benefit are distributed. Yeah, and to me, what is important is that we look at the bottom 50% because they are the one that we need to sort of pay more attention to, because we want a world where it is more equal, where we want to reduce the suffering of the poorer people. We want a more inclusive world. Yeah. So even if it results in some, we should not begrudge the entrepreneur who become billionaire, so long as it is not ill-gotten gains. Yeah. So we are creating value, and of course, how this value can be distributed, as I said, can be shaped. So in a stakeholder capitalist system, it will be distributed more equitably. It will not be at the expense of the future generation, for example, because now, for example, many companies produce their product and solution are not environmentally sustainable, and so they pocket this private returns. But in a truly stakeholder capitalist world, that will not be allowed, right? More conscious impact investor will say, no, I don't want to invest in a company that does it. And young people will say, I don't want to work in a company that do it. And a consumer say, I don't want to buy a product where the company is not ethical or the company is not having this poor environmental record. And that's why B Corp is important, because we provide the information. We are not the only one, but the point is that you have information that the consumer, that the employee can look at what is your track record as a company? Do you only generate returns to a small group of shareholders, or do you care about these other things? Yeah.
Prof. Wong, I think there's a black rectangle appear and then we cannot see your contact information on the screens.
Yes.
Yeah. Okay. So there's some Prof. Wong, you mentioned about this B certificate, right? There's a question asked: can SME afford the fees, the B certificate fees?
Can SME afford to
pay the B certification fees?
Okay, the B Corp has a fee schedule which depends on the size of the company. So if you are an SME with small number of employees, the cost is quite low. Whereas if you are a big listed company, with thousands of employees and many different operations, then of course the cost will be higher. B Lab itself is a social enterprise in a way. Yeah. I mean, you can find out more information about anyone interested in this. You could drop me an email. I'll be happy to connect you with the founder of B Lab Southeast Asia. Yeah.
Okay. There's another question from Utah alumni. They are now working on the Industry 4.0 connectivity system integration. So the question is that what will be your advice on how can they educate their customers to adopt these technologies? They have strong resistance on adopting these solutions and they don't think data is important for them and they prefer manual key-in compared to integrated systems.
Sure. Yeah. Okay. This is a good question because organizational resistance, as I mentioned, is the bigger challenge to innovation. Yeah, because a lot of time, and organizations are so used to the old way of doing things, they are complacent. Also, they got legacy systems that they have invested in. I guess the general answer I will give is that you need to find the real pain point of your customer. In other words, you cannot do a solution push. You cannot say, I have a solution that please take it. You must really understand what is the real problem of the customer and solve that problem first. So the way, which is why I think it's important to find the right problem to solve, right? Remember the example of that fishery, right? It starts with the understanding of the problem. And then you come up with a solution that addresses the problem. So it could be that sometimes when you try to push a solution to a customer and say, I don't want to absorb it, yeah, of course, there are some other factors. It could be two reasons. One is that you're not talking to the right party in the organizations. For example, the IT, the CIO, for example, who have built their own legacy system, right? He may be resistant to change because he's building an empire. He wants to build all his own solution, and if you tell him that your solution is actually outdated, it implying that he's not doing a good job. So of course he was defended, right? But for example, if you talk to the CEO, the boss is more concerned with how can I improve productivity, how can I improve the operation of the company. And so sometimes maybe that you're not talking to the right user. But in other cases, it's because maybe the problem you're addressing is not the most urgent questions. Because you must look at it from your customer endpoint. A customer at any one time may have many problems. The problem you identify for them is a problem, but may not be the most important problem. And so you really have to put yourself in the shoes of the customer and figure out what is most important to that customer.
Yeah. Great. So a related question is that beside the resistance from the companies to adopt this one, what do you think are I'm combining these two questions now. What are the other challenges that cause Malaysia is slow in adopting this technology? And another question related is do you think government leadership in creating and nurturing a stakeholder capitalism environment is important?
I don't pretend to be able to give any advice about Malaysia because I have not been following Malaysia that closely in recent years. But obviously, I think the point I raised before, which is that you need to encourage entrepreneurship, and you need to sort of give them the freedom to operate, and if possible, to sort of plug the gap in the initial stage. Because if you look at the whole entrepreneurship development process, usually at the very early stage, that's when the help is critical. So funding support, like maybe Cradle has done and all that, is good, but maybe there could be more that can be done. But the other big challenge I sense is that, and it may not be specific to Malaysia, but it is something to perhaps it may be an issue as well, which is that many young people, technically talented, they are good engineering skill, good technology, but because they don't understand the real customer problem. So they cannot come up with a really sort of relevant solutions. So the challenge here will be that how can we get the technical talents to really go out and understand real world problem and bring this back, and then think about what their skill can be used to solve those problems. And the buzzword, a lot of people when they teach about innovation is to think out of the box, right? I think it's very common, right? My advice is that don't think out of the box. Think out of the box means you sit inside your office, you sit in the campus, and you think of what wonderful your technology can do. You should get out of the box. You should go, if you think you're going to solve some problem, go to the agriculture farm. Go to the rural villages, go to wherever you think there's a need, and see the problem from that angle. Then only you can come back and say, okay, what would be the best solution that can be implemented, that is feasible. Now, sometimes it may require some interim, very low-cost solution, because these people may not be able to afford too expensive system. Remember the simple sort of digital camera with a transceiver, right? Small businesses aren't going to pay a lot for very expensive smart meter. So you can think about simple solution, because that is what that sort of market can pay for. So generally, my advice would be that, especially for the technical talents, is to understand more about the market needs of the company. And then for the business student, and I understand you have a lot of business students, it's important for business students to be able to work in a team with engineering and technical students, right? Because entrepreneurship is not a solo effort. It is a teamwork. And the idea is that you bring in the people who have different skills to complement you to work as a team.
Yes, I think that's really a very good advice. And then we have a question from the Philippines. In the Philippines, there are studies which show that SMEs are helped, but when they get to be MSEs, there is difficulty for advancement. What are your thoughts on this?
What is MSC?
SME and MSE.
SMB is small and medium-sized business.
I think if I get it correct from the participant, Chiao Feng, right? MSE is the medium size, right?
Medium size, okay. So what's the question again?
There's difficulty for when they are in MSE, they are helped, but when they get to be MSEs, there is difficulty for advancement.
Okay, if I think correctly, you say that medium-sized company,
when they are small, they are being helped, and when they get to medium size, there is difficulty for them to advance further.
Okay.
No help for medium enterprises.
All right, so you're saying that it's easy to go from a small business to become a medium size, but it's difficult to go beyond it.
There's a further clarification. I think that there's less assistance given to the medium enterprises.
Oh, okay. About assistance given, okay.
And therefore difficult for them to advance.
Okay. Again, without knowing the specific detail, it's hard for me to say. But by right, government policy would be to help those who are more in need. So if you are a medium-sized company, everything else equal, you need less help. And so without going into the detail, it may not be wrong for the government not to sort of provide direct help to a medium enterprise company. But having said that, however, I will also want to say that government policies must also look at it not from the standpoint of the individual company, from the standpoint of a whole industry development and a standpoint of the infrastructure to support a whole industry. So it need not be help that are directed at specific companies. And that may be more important, especially in dealing with a company that are in perhaps a more medium-sized stage. I will also say that a lot of times the companies are often thinking too much about just doing things themselves, but very often the power of the digital integration with physical system that 4IR is about really requires something to be done at the industry level. And so you need to have form partnership, you need to cooperate. For example, everybody might adopt the same standards. If you adopt one standard and adopt another standard, then the technology cannot take off. If you have technology as supplier cannot talk to the buyer, right? So very often for IR 4.0 technology to be successfully implemented, you need to look at the whole value chain. You need to look at the whole ecosystem. And that means that, you must look at what is the gap in that ecosystem, and the government policy is directed at that gap. Rather than say that, just because you are medium size, I give you something, you're small size, I give you something. It should be more understanding the needs of the ecosystem and how we encourage this cooperation. How can we encourage the building of a critical mass? Because again, very often you don't have a critical mass, individual adopting some solution will not work.
Yes. Okay. Due to the time constraint, I think we had the last questions that I would like to address about Singapore. Could you enlighten us with information in Singapore government in promoting Industry 4.0 effort, both academically and an industry perspective?
Well, this is a topic that for another talk, yeah. But I mean, there are a lot of information out on the in the internet that you can search and you can find. A lot of government policies are sort of well publicized. I would say that among some of these that are being publicized, perhaps I just want to highlight a couple. One is the emphasis on skill development. So the Singapore government, for example, had a skill development fund that actually enable everyone to essentially avail this funding support to redevelop themselves, to acquire new skills. Now, this is important because very often, even if you're an employee with a company may provide you with training, but company wants to train you in things that the company are interested in. But very often you want to train yourself in skills that is not in use in your company, but that is to prepare for you to be able to move into a new industry or new application, right? And so that sort of encouragement of continuing education and strong funding support to redevelop and retrain for essentially the digital world, I think it's important. And that extends to even individuals, people like my age, even elderly who have retired, but they can still become more productive by learning how to make use of a lot of these digital technologies. And so this focus on encouraging lifelong learning and encouraging upgrading of skills, I think it's a program that is worth looking at for some other countries. The other thing to recognize about Singapore is that Singapore has a very small domestic market. And so we need to encourage our young to really think about if you were to build any viable sort of digital technology-based business, you must think about how to go out internationally. Yeah. So in this regard, I think education play an important role. So, for example, when I was director of NUS Transformation Center, one of the entrepreneurship education program we built is to actually get our students to go out of Singapore. They spend a year working as an intern in early stage high-tech startup company around the world, in Silicon Valley, in China, in Israel, and so on, so that for them to actually see for themselves the world market, and to get a sense that how I can build businesses that not just meet my small Singapore domestic market need, but that can be scaled to the world. And I think therefore, for maybe Malaysia, you have a much bigger country, you have a much bigger domestic market, but perhaps this emphasis on perhaps getting your young people to be more exposed to the rest of the world and to be more sensitive, to have more empathy towards other culture, other society need, so that you can think through your business model that is more, that can be translated across different parts. I think that will be important. So maybe Utah, you're already doing that, but I think generally I will encourage more of that to be done. Yeah.
Thank you so much, Professor Wong. Thanks, for answering all these questions. I think we all have learned a lot during this talk. Thanks for your great presentation. It is really a great pleasure, to having you and then listen to your talk again. Thank you, Professor Wong, and thanks everyone for your participation today. Shall we take a group photo?
Sure.
Okay. Maybe Professor Wong, I will unshare your screen so that we can see. Okay. Yeah. Can you all turn on your video so we will take a group photo with Professor Wong? Thank you everyone, for your participation, especially to Professor Wong.
Thank you for your participation, and if you have any questions, just drop me an email. Yeah.
Okay, are we ready?
Any comments and suggestions as well? Yeah.
Yes, I think Ms. Scott, can you help us to take the photo?
Yes. Get ready. Okay. 3, 2, 1.
We have many pages, huh?
Yeah. Yeah. Okay. Thank you.
Okay. Thank you very much. Okay. Bye-bye.
Okay. Thank you. Thank you, everyone.
Thank you. Bye-bye.
Thank you, Professor Wong.
Thank you, everyone.
Have a good day.
Thanks, Prof. Wong. Thanks, Prof. Cheng.
Thank you.